Hi, so the third method in solving a linear system is solving by elimination, and this is also an algebraic method, slightly different from substitution, but it will give you an algebraic solution. Whereas in graphing, sometimes you don't get an accurate solution, whereas in substitution and elimination, since they're algebraic method, you will get an accurate solution. The goal here is to eliminate one of the variables by either adding or subtracting equations in the system. So step for solving by elimination is, again, the first step is the same in both cases, substitution and elimination. You're going to label each of your equations. Second one is you're going to multiply one or both equations by a number that allows for the elimination of one of the variables. And I'm going to talk a little bit more about this as an example. And here what you're basically doing is you are just creating a multiple of that equation. Then you're going to add or subtract to eliminate one variable and solve for the remaining variable. You're then going to substitute this value into one of the original equations to solve for either of the variable. You're going to then write a concluding statement with your coordinate as x and y as your solution. Okay, so the first example here is we're going to solve this by elimination. You're going to start off by labeling your equation. Again, this is a linear system because you're dealing with two equations simultaneously. And our goal here is to eliminate a variable. So whenever we're doing that, the first thing you got to do is make sure that the coefficients are lined up with the subsequent variables. So in this case, you have to make sure that the variables are lined up, the x's are lined up, the y's are lined up, and then I have my numerical digits lined up as well, along with my equal signs. So in this case, I'm going to eliminate a variable. In order for you to eliminate a variable, you got to make sure that the coefficients in front of that variable is exactly the same. If it's not the same, then you multiply either one of your equations by a number so that you do get the coefficients to be the exact same. So in this case, if you notice, the coefficient in front of the y is same. Don't worry about the signs, just the numbers you're looking at. So here I have a 3 and here I have a 3. The signs are different. That doesn't matter. When you're eliminating a variable, you can either add or subtract. And one of the rule of thumb is when you have the same signs, you're going to subtract. So I'm going to write that down right there for you. So same signs, subtract. So the way I remember it is both of them or all three letters here start with S. So same sign, subtract. And again, if they're different signs, you're going to add. So in this case, they're different signs, so I'm going to add both of my equations. Let's go ahead and do that. So 2x plus 4x is 6x. 3y plus negative 3y is basically a 0y. What you're doing is you just eliminated that variable. So that variable just eliminated. And then I have negative 4 plus negative 8, that's a negative 12, equals 0 plus 0 is 0. I'm going to go ahead and solve for x, move the negative 12 to the other side, and I'm going to divide both sides by 6. X equals 2. And then it's the exact same thing as what you've been doing in substitution. You're going to put that solution into any one of the equations, either 1 or 2, and solve for the subsequent variable. So here I'm going to say sub x equals 2. I'll plug it into the first equation. So anytime I see an x, I'm going to put that in as 2. So 2 times 2 plus 3y minus 4 equals 0. That's a 4 plus 3y minus 4 equals 0. 4 minus 4 is 0. So if 3y equals 0, divide both sides by 3, y equals 0. So therefore, my solution is x comma y, which is 2 comma 0. Okay. Let's try another example. I'm going to start off by labeling your equation 1, equation 2. And I'm going to just make sure that my variables are lined up. So x's are lined up, y's are lined up, my numbers are lined up. The same thing with my equal signs. And I'm going to try to eliminate our variables. So I'm going to see which variable I can eliminate. So here I have a 3 and here I have a 1. Here I have a negative 2 and I have a negative 5. So neither one of the coefficients in front of the variables are the same, but I can make them the same by multiplying an equation by a coefficient. So here if I multiply this whole equation by a 3, I can get that number to be a 3. So that my coefficients in both of the equations that are lined up for x would be the same. So I'm going to multiply this equation number 2 with 3. So that means each one of my variables and my numbers get multiplied by 3. So every term is going to be multiplied by 3. So 1 times 3 is 3x. Of negative 5 times 3 is negative 15y. 4 times 3 is a 12 equals 0. My first equation, I'm going to keep it the same. So I have 3x minus 2y minus 14 equals 0. So that's my first equation. Since I multiplied this equation by 2, that becomes a new equation, which is equation number 3. Alright, now I'm going to decide, do I subtract my equations or do I add them? So since they have the exact same signs, the positive 3 and a positive 3 here, so same signs means subtract to eliminate a variable. So 3x minus 3x is a 0x, so basically I've just eliminated that variable. I have negative 2 minus negative 15, so it's negative and negative 15 make a positive 15, and then a minus 2 is going to be a positive 13y. Negative 14 minus 12 is a negative 26, and then 0 minus 0 is 0. I'm going to go ahead and solve for y, move the negative 26 to the other side. So positive 26, divide both sides by 13, y equals 2. You're going to then sub y equals 2 into any one of the equations. I'm going to put it into equation number 2. So I have x minus 5y plus 4 equals 0. X minus 5 times 2 plus 4 equals 0. X minus 10 plus 4 equals 0. And move this to the other side, so negative 6, move it to the other side, becomes a positive 6. Therefore, my solution is x comma y, which is a 6 comma 2. Alright. Let's try another example. I'll do example 3 in class. And I'm just going to move on to example number 4, which has fractions, something different we haven't seen before. So I'm going to start off by labeling equation 1, equation 2. And I don't like working with fractions too much, so I'm going to get rid of them. And to get rid of a fraction in an equation is to multiply every term by the common denominator. So in this case, my common denominator for my first equation between 3 and 4 is 12. So I'm going to multiply every term with 12. I'm going to just use a, well, I'll use a pencil here. Multiply this by 12, multiply this term by 12, and you're going to multiply this by 12. Okay. And when I do that, you're going to notice some things canceling out, because 3 goes into 12 4 times, and then 4 goes into 12 3 times. And here I don't have a denominator to get rid of. So I'm going to rewrite this as 4 times x is 4x plus 3 times y is 3y equals 12 times 2 is 24. And that's my new equation, which I'm going to write as equation number 3. For the second one, I'm going to do the exact same thing. There's fractions here. I want to get rid of them. So you multiply every term by a common denominator. And the common denominator here is a 6. So between 3 and 2 is a 6. Multiply this term by 6, this term by 6, as well as that term by 6. 3 goes into 6 twice, 2 goes into 6 3 times, so I have myself a new equation now. 2 times 2x is a 4x. So if a 3 times negative y is a negative 3y, and then 6 times 0 is a 0. And that's my new equation. I'm going to label that as equation number 4. This is so much easier to work with because you're dealing with equations that do not have fractions. So then, in order for me to eliminate a variable, I'm just going to make sure that my variables are lined up. So x are lined up, y's are lined up, numbers are lined up, same thing with my equal sign. And in order for me to eliminate a variable, I got to make sure that the coefficient in front of the variable is exactly the same. So here I have 4's, they're the same, as well as the 3's that are the same. So I have a choice. I can either eliminate x or I can eliminate y. So here I have same signs I can subtract. Here I have different signs I can add. It's a little bit easier to add than to subtract. So I'm going to add my equation and to get the y's. So 4x plus 4x is 8x. 3y plus negative 3y is 0y, so eliminated that variable. And then 24 plus 0 is 24. And then I'm going to go ahead and solve for x. So that's 8x equals 24. Divide both sides by 8. X equals 3. You're going to sub x equals 3 into any one of the equations 1, 2, 3, or 4. I'm going to put it into equation number 4. It's a little bit easier to work with. 4x minus 3y equals 0. Anytime I see an x, I'm going to plug in a 3. So 4 times 3 minus 3y equals 0. That's 12 minus 3y equals to 0. Move the negative 3 to the other side. And I'm going to divide both sides by 3. Y equals to 4. So therefore, my solution, x comma y, is going to be 3 comma 4. Great. And I think I will do this one in class as well. Let's do the last example here. We're going to start off by labeling our equation. Equation 1, equation 2. Make sure my variables are lined up. X are lined up, Y's are lined up, equal signs are lined up. Same thing with my numbers. To eliminate a variable, the coefficients in front of the variable must be the same. Here I have a 2 and a 4, they're not the same. I have a 1 and a 2, they're not the same. So I'm going to go ahead and multiply my first equation by 2 to make sure that I get the same coefficient. So here I'm going to have 4x. So negative 1 times 2 is a negative 2y equals 2 times 2 is a 4. And that's my new equation, equation 3. The second equation, I'm going to leave it as it is. And I can eliminate a variable. So here I can eliminate x or eliminate y. See, there are different signs here, so I'm going to go ahead and add. And there are different signs here as well, so I'm going to add that as well. So when I add this, I get 4x minus 4x is 0x. And then negative 2y plus 2y is a 0y. And then I have 4 plus negative 4 is 0. So here I have 0 times the number equals 0. That means y can be any number. With y, it can be any number. So if you choose a y as 2, you're going to get a subsequent x. So therefore, there are many solutions to this equation. So therefore, there are many solutions. Okay. That's it. And the homework is the following, which we're going to do in class. Thank you.